We're on D, number 3. And again, we're trying to rewrite this implicit equation as a collection of explicit equations. So basically, we're solving for y. So the first step for this one is we're going to divide by 4 minus x. So y squared is going to be x cubed over 4 minus x. And then y is going to be either the positive square root of x cubed over 4 minus x, or y is going to be the negative square root. So y is two functions combined, the positive square root of this thing and the negative square root of this thing. Okay, and if you want, you could also write this like this. You can square root top and bottom. This would be x to the 3 halves over square root 4 minus x. Whichever you like better. This one might be a little bit easier to derive. And this is going to be negative x to the 3 halves over the square root 4 minus x. So when we derive them, they should be the same exact thing, except for one's going to be negative, one's going to be positive. So we can do that real quick. Just looking at this, dy dx is going to be, using our quotient rule, 3 halves x to the 1 half times square root 4 minus x minus x to the 3 halves times 1 half 4 minus x to the negative 1 half times the derivative of the inside, which is negative 1, over the bottom squared, which is just 4 minus x. So I'm going to rewrite this up top here. We're getting dy dx from this is, simplifying this a little bit, these negative 1 and minus turn into a plus. We don't want, let me think here, the 1 half here, the 3 halves here, we're going to multiply by 2 on top and bottom. And we're also going to multiply by 4 minus x to the positive 1 half, because I do not want that 4 minus x to the negative 1 half up there. So when we multiply through, we're going to end up with, the 2's are going to cancel, 3 x to the 1 half, 4 minus x to the 1 half times 4 minus x to the 1 half is 4 minus x. Times, no, plus, sorry, x to the 3 halves. The 2 is going to cancel with the 1 half. This is going to cancel with this, and that's all we're left with. Over 2, 4 minus x to the 3 halves. Okay, we can get rid of all this. Well, almost all of that. Cancel, and just to, I'll rewrite this in green so we know it's the derivative. Simplifying this down even further, dy dx is, we're going to have 12x to the 1 half right here, minus 3x to the 3 halves plus x to the 3 halves, that's minus 2x to the 3 halves, over 2 times 4 minus x to the 3 halves. And 2 can cancel because 12 is divisible by 2, 2 is divisible by 2, and it's really 6 x to the 1 half minus 2x to the 3 halves, 1x to the 3 halves, I'm sorry, 1x to the 3 halves, over 4 minus x all to the 3 halves. There you go. That's our derivative. Now, if we derive the other one, this negative one, we'd have the same exact derivative because it's the same exact thing, except it would be negative. So it would be the opposite of this thing. Cool. So dy dx either equals this, or dy dx equals the opposite of this. Okay. Get out of here. Alright, we're going to do this explicitly now and show it's the same thing. Deriving the first part, we got to do the product rule, so it's going to be negative 1, deriving 4 minus x is negative 1 times y squared, plus 4 minus x times 2y dy dx. That's going to equal 3x squared. Okay, and then solving this for dy dx, maybe we should do it in blue so we know it's the implicit version, is going to be 3x squared plus y squared over all of this, 4 minus x times 2y. Okay, 4 squared over this. There we go. That's our derivative. Now, our goal is to show that this derivative and this derivative are the same thing. And what we're going to do really is plug in what y equals. So, y is this big fraction. That's going to be a little bit hard to simplify down. I'm going to do it in one case, and you can plug in the negative case and see it's the same thing. But we have 3x squared. Let's go ahead and plug in this one right here, square root of x cubed over 4 minus x. Okay, when we plug it in, we should get this same exact thing. I'm going to do it on the next page. So we have 3x squared plus y squared. Let me write this. 3x squared plus y squared over 4 minus x 2y. And that's going to equal 3x squared plus, now we got to plug in y. This thing squared is just x cubed over 4 minus x. So it's x cubed over 4 minus x. All over 4 minus x times 2y, which is 2 square roots of x cubed over 4 minus x. Okay, now we got to show that this thing is equal to 6x to the 1/2 minus x to the 3/2 over 4 minus x to the 3/2. Well, mostly we just don't want this 4 minus x here. So we're going to multiply the top and bottom by 4 minus x. Okay. Now we're trying to get this thing right here. We'll multiply the top and the bottom of this big fraction by 4 minus x, and that's going to give me. So think about this: 4 minus x over 4 minus x times this whole big fraction. 3x squared times 4 minus x is 12x squared minus 3x cubed plus 4 minus x times this is just x cubed over 4 minus x times this stuff. I'm going to leave this 4 minus x alone, and then 4 minus x times this part right here is going to cancel with the square root of 4 minus x on the bottom, which is going to leave us with another 4 minus x to the 1/2. And then we're going to have 2 x to the 3/2 because it's in the square root, so x to the 3/2. Cool. Well, right here you can see we have 4 minus x times 4 minus x to the 1/2. That's going to work out nicely because that's 4 minus x to the 3/2. 12x squared minus 3x cubed plus 3x is cubed. Oh yeah, plus 3x cubed is minus 2x cubed. So we have 12x squared minus 2x cubed over, and you can see this is turning out to be very nice, to the 3/2 times 2x to the 3/2. Dividing everything by 2 becomes 6 and 1. And dividing by x to the 3/2, x squared divided by x to the 3/2 is x to the 1/2. X cubed divided by x to the 3/2. This is 6/2, so minus 3/2 is 3/2. And you can see we are going to get the same exact thing. So that's your goal. If the question says that, show that they're the same, so the derivatives are the same. You derive it, plug in what y equals, and simplify down until you get the same thing. That's all. All right. Let's clear this out of here. The last one, we can do it real quick. We're going to get y is equal to, you're going to divide by 4. So that's 4 plus x squared over 4. And then we're going to take the square root. So you're going to get the plus, the positive part of that, and then you're going to get the negative part of that. So 4 plus x squared over 4. And those are both really 1/2, because square root of 4 on the bottom is just going to be 2. The square root of 4 plus x squared, or negative 1/2 the square root of 4 plus x squared. And the same thing is going to happen with this. When you derive it, you're going to get the same exact derivative, just one's positive and one's negative. So we'll just derive one. We'll derive the positive one. And we're going to get this to the 1/2 turns into 1/2 times this, so that's 1/4. 4 plus x squared to the negative 1/2 times negative 2x. Oh, that's plus, so times positive 2x, sorry. And that's going to be 1/4 and 2 cancel to 1/2. X is on top. 2 square roots 4 plus x squared. Cool. And remember, y was equal to this thing right here. Okay, now we got to show that deriving this implicitly gives us the same exact thing. So I'm going to cancel out this negative. I'm just going to delete it so I have some more room to work here. But remember, the derivative is either this thing here or the negative of this thing if we would derive the other y. Now if we derive it implicitly, we're going to get 8y dy dx is equal to 2x. Meaning dy dx is equal to x over 4y, which looks much, much nicer than this whole mess here. But it's the same thing, and you can see that because x and x are both on top, and 4y, well remember, y was this thing, 1/2 the square root. 4 times this is 2 those square roots, which is exactly what we have here. So, and you could write that, equals x over 2 square roots 4 plus x squared, which shows it's the same thing. And if it was negative, then we'd have negative y, and it would simplify out to the same exact thing. All right, we'll do the second derivatives in the last video.